Hi everyone, welcome to the regression analysis lecture. This is one of the subjects in the Statistical Science Study Program, Department of Mathematics, University of Indonesia. We still progressing with the model building. We've done with one predictor for quantitative, two predictors, more than two predictors for quantitative. We've done that. For the qualitative, we've done with one predictor of two levels and three levels. And now we will discuss about what if I want to change the code of the levels or I want to change the baseline. Will it affect the result? So that's what we are going to see now. Okay, so just making use the result from the previous one, okay, in the dummy variable or categorical variable with 2 and 3 levels. Before we have here for the 2 level, okay, in the previous one we have for 2 levels, we have run and then the result is like this, okay, we are given that, okay, we have this result. Okay, so male, and then the coefficient of male is 6 point something. Okay, if we have this. Okay, so in here, previous one we have male and the baseline is female, and then we get, okay, 18.06. Okay, this is just rounding error, 15. Okay, so from the previous result with the baseline of female, we have the result is 18.06 plus. Okay, this is just some variation due to the rounding error, I think, 68. And then, so here we have 18.06. Okay, and then, so now we want to try to do the recode. If I change the coding, will it affect the result? The result in here is that the relative comparison on the effect of gender on the measurement of Y. So in this case, instead of 1 for male, I want to have 1 for female and 0 otherwise, which means that the baseline is the male. So actually the other way around with the previous one that we've done. Okay, so in this case, because we have two levels, we have two models actually, one model for each of the level. So model for males in this case is just beta naught, okay, because for males then x1 equals 0. So here we have beta naught, and model for females is that beta naught plus beta 1, because okay, it should be the whole thing. So model for males actually, yeah, just the same between males and females. Okay, however, now we look that here for males, x1 should be 0, so it consists of just the intercept. And then for females, x1 equals 1, so here is beta naught plus beta 1. Okay, now without even doing the calculation, I mean the running the data, I can guess that what is the estimated value of beta naught and beta 1 from the previous result. Okay, so I can guess that here I can get males should be the estimated value for beta naught if we run this model should be just this one, 18 plus 0.6, maybe some variation due to rounding error. It should be just this number, and for female it should be just 18.06. Okay, so in this case, then I will get that estimated value for beta naught is like 26.6.76 around that, and for beta naught this is for just beta naught, this is for beta naught plus beta 1. It means that I can say that the beta 1 should be okay, so the beta 1 should be negative. Okay, so that beta 1 should be negative of 8.68. Is it like that? If beta naught is 26, yeah, beta 1 should be minus 8.68. Okay, so you can see that probably the estimated value of beta naught and beta 1 might be different. For the first coding, okay, the first way of coding, we know beta naught is 18. For the second, if we change the coding, we will get beta naught is 26. For the first one, where female is the baseline, the beta 1 is that, where is the beta 1? Beta 1 is 8.68 in here. Then for the second, the what is it? Way of coding we get beta 1 is minus 8 because it just makes sense. Okay, so we say here male is 8.68 higher than female. If we change the coding, then we will say that female is 8.68 lower than males. Okay, let's try to do how to do it in R. Okay, so let's try to do it, the coding. So how do I code it? We want that one female. Okay, so then we just do like this, female. If x equals female, then assign 1, otherwise assign 0. And then we fit the model. Okay, here we get that female. Okay, and as you can see that compared to the result that we've got here, okay, compared to the result that we got here, we get the intercept is 26.76. Okay, and this is for males actually, and then for females beta 1 is minus 8.68. Okay, so from this example, no matter it doesn't matter how you create the dummy variable, you can have kind of like different baseline, different coding, but and of course the corresponding estimated parameters will be different, but the interpretation on the relative contribution of the explanatory variable to the response is still the same. Now we will look for the what if for three levels, okay, categorical variable with three levels. This is from the previous example. Okay, the result that we got, actually if we want to see it again here, okay, so for three levels previously we have something like this. Okay, so we have orange and red, and the baseline is what is it, the blue colors, so orange and red. And so we have model for orange is 0.8. Okay, again this is just what is it, due to the rounding error, or if we just follow that one, so 0.80 plus orange is 17.04, and then for red is 0.80 plus 26.00, and then for blue as the base level is 0.80. Okay, that's the one that we've got here. Now for example, you don't want to follow that kind of coding. Okay, so you want just, I want to have the baseline is, instead of blue, I want it to be orange. Okay, so I want the baseline is the orange color. Okay, so it's okay, and then I want it, okay, the first indicator is for red, the second indicator is for blue. Again, actually, without have to do rate estimation, we can just what is it? We can just guess, or we can derive the estimate for orange, red, and blue. So in this case, we have it. Okay, I just copy this and paste it in here for orange, for red, and for blue. Okay, now for the orange, according to our modeling here, orange is that, so x1R should be 0, x1B should be 0, so orange consists only the intercept, that's for the baseline, and red here, so x1R should be 1 and the other is 0, so here we have this one for red, and for blue, x1B is 1, but red is 0. So we have beta naught plus beta 2. Okay. Now, what about the estimated value for beta naught, beta 1, and beta 2? We can just get it from the result of the previous one. For example, here orange is 80. So 0.80 plus 17.4. So should be the same here. Okay. So it's just the same. And then for red, it's 0.80 plus 26 is also the same. I just copy the red here. And for blue, zero point 0.8, yeah, this is also just 0.8. Okay, so now we can see that, okay, so here, which means that beta naught is 17.84, and then the what is it, the red is this one, so we know that what is it, just this is the beta naught. Okay, 17.84 is the estimated for beta naught, and then for beta 1 here we can say, we can guess that beta 1 should be I mean that it's okay, beta 1 should be beta naught, okay, beta 1 should be 0.80 plus 17.4, right? And then, so it should be, I just copy paste this one, that is the beta naught, okay, because beta 1 should be the whole thing here, sorry, this whole thing is beta naught plus beta 1, so beta 1 should be the whole thing here minus beta naught. Okay, so it means that beta 1 should be the whole thing here minus beta naught. Beta naught is the one that we've got up here, so we have this one. And then so the result is 0.80 cancel out, so 26 minus 17. 26 minus 17, we get it 9, right? So it's 8.96 should be. And for blue, here beta naught plus beta 2, so we can just guess, okay, so what is the value for beta 2? So for beta 2 should be the whole thing here minus beta naught, right? So the whole thing here minus beta naught, and beta naught is the one that we get up here. Again, I just copy and paste it here. And then we have it it is minus 17.04. Okay, so this is our what is it, estimated value for beta naught, beta 1, and beta 2 if we change our codes for the dummy or indicator variables. And then it should just make sense. I mean that for here we can say orange is 17.4 larger or greater than blue. So then we can say here blue is 17.4 lower than the baseline is orange. Okay, so the story is just the same but represented in a slightly different way. If we want to confirm it, then we can just do it in R. Okay, so here we want it red and blue. So then this is how we record our data. So red, we create variable red, put what is it, indicator 1 and 0 else, and then blue, put 1 if you want it to be um, blue. If you want to see the data, your data is like this. Okay, this is our just new created variable. So if it is red, you put indicator 1. If it is blue, here you put indicator 1 for blue. So for orange, then both indicators are 0. Okay, so then if we try to run it, here we get the result, and then uh, as from our what is it, from our calculation here, is it this one here, so we can see that beta naught is 17.84 for what is it, beta 1. For red it's 8.96, and then beta 2 for blue is minus 17. Okay, so what can we conclude from this illustration? That is, if you want to change the coding of levels of the categorical variable, yes, the estimated parameter is changed. However, the interpretation on the effect of each level of the categorical variable relative to the response variable is still the same.